We've mapped more of Mars than we have of our own ocean floor. And beneath those oceans, beneath the crust we walk upon every day, lies a world almost completely unknown, a planet within a planet. We call it Earth. Yet much of it remains a mystery. When we look up, we see the sky, infinite, open, beckoning. When we look down, we see solidity, stability, the illusion of knowing where we stand. But beneath that surface, the ground itself becomes a question that has haunted human beings since the first stories were told around the first fires. What lies below? In nearly every ancient culture, the answer took the shape of an underworld. The Greeks imagined Hades, not a place of punishment, but of permanence, where the souls of the dead drifted among shadowed caverns. To the Norse, it was Niflheim, a cold, misted realm beneath the roots of the world tree. The Mayans spoke of Xibalba, the place of fear, where trials awaited the spirits of the departed. And in each myth, the descent was never easy. It was a journey through layers of earth, of meaning, of self. But those were stories, and over centuries, myth gave way to measurement, philosophy turned to physics. The underworld became geology. And the same question remained, reshaped. How deep can we go before we can no longer go further? The first thinkers to question the Earth's interior had only imagination to work with. Aristotle believed the planet was composed of concentric spheres, earth, water, air, and fire, perfectly ordered, perfectly balanced. By the Renaissance, scientists had begun to suspect something less tidy. Earthquakes, volcanoes, magnetic fields, all hinted at a living, dynamic interior, a planet that shifted and breathed beneath its crust. Still, for most of human history, the deep Earth was unreachable. Our tools could scratch only the surface. Even the deepest mines of the 19th century, miles of tunnels carved by human hands, were barely a pinprick in comparison to the planet's vastness. To imagine the scale, if the Earth were an apple, the deepest hole we've ever dug wouldn't even break the skin. Yet curiosity is stubborn. It doesn't rest when it finds resistance. It presses deeper, asks again, and somewhere between science and story, a new ambition began to take root. The dream of piercing the planet itself. In the late 19th century, scientists began to read the Earth in a new way, not by sight, but by sound. Seismology was born. Every earthquake became a revelation, a pulse through the planet that could be measured, decoded, translated. By studying how waves of energy bent and slowed as they passed through different materials, scientists could infer the structure of the unseen. They discovered that the Earth wasn't uniform, but layered, a thin crust, a vast mantle, and at its heart, a core of iron and nickel. This wasn't myth anymore. This was measurement. But even with all their equations, there was a limit to inference. Data could tell us how the planet behaved, but it couldn't tell us what it felt like to be inside it, what the rocks, the heat, the silence were really made of. And so, in the 20th century, a new era began. An era of drilling, not for gold, not for oil, but for understanding. The story of our descent begins not with the Soviets, not even with the Cold War, but with the ocean. In the 1950s, American scientists conceived something extraordinary. Project Mahole. Named after the Mohorovičić discontinuity, the boundary between the crust and the mantle, it was a plan to drill through the ocean floor, where the crust was thinnest, and reach the very edge of the unknown. The idea was bold, maybe impossible. But that was the point. If humanity could reach the stars, could we not also reach our own foundation? They began off the coast of Mexico, in waters 5 kilometers deep. From a converted barge, engineers lowered drill pipes section by section, like a needle into the planet's skin. The technology was untested, the risks immense. And yet, they succeeded, briefly. In 1961, the drill reached 183 meters below the ocean floor. It wasn't far, not compared to the scale of the Earth. But it was further than anyone had ever gone before. The project was hailed as visionary and doomed by politics. Funding vanished, priorities shifted, and the dream sank beneath bureaucracy. Project Mahole ended not with discovery but with silence. But in another part of the world, that silence was being listened to very carefully. And in 1970, on the frozen Kola Peninsula in the Soviet Union, a new hole began to open. One that would go deeper than any before it, and perhaps any after. Before we follow them there, before we descend into that spiral of heat and stone, it's worth pausing to consider something. Why do we dig? Why, of all directions, are we drawn down? Maybe it's because the surface of things, whether in the earth or in ourselves, is never enough. We live on the crust of experience, thin and fragile. And somewhere inside we sense that more lies below. To dig is to confront the unseen, the unmeasured, the layers of history and meaning compacted beneath our daily lives. Every excavation, geological or personal, reveals not just what the world is made of, but what we are made of. The Earth's crust holds our oldest memories, fossils of life long extinct, the fingerprints of vanished oceans. Each layer is a chapter in a book written over billions of years, a record of time and transformation. When we drill into it, we're not violating nature, we're reading it. But like any great book, there are pages missing. And in the case of the planet beneath us, most of the story remains unread. To put our reach in perspective, the Earth's radius is about 6,371 kilometers. The deepest we've ever physically gone, the Kola Superdeep Borehole, is just over 12 kilometers. That's less than 0.2% of the way to the core, a fraction so small it almost disappears in proportion. And yet, for all its insignificance in scale, that descent changed the way we see our world. Because in those 12 kilometers, we encountered things we couldn't fully explain. Temperatures that defied models, rocks that behaved like liquids, and sounds that stirred something ancient in human imagination. But that comes later. For now, the story begins with a dream, the oldest kind of dream, to touch the unknown. The scientists who stood at the edge of that Arctic drilling site weren't seeking fame or fortune. They were seeking knowledge. In their minds, every meter drilled was a meter closer to the planet's heart. Every vibration in the drill string was a whisper from below, a message from the deep earth. They called it the well to hell, not in jest, but in awe, not because of what they feared, but because of what they hoped to find. Throughout history, humanity's greatest acts of exploration have shared one quiet truth. We rarely find what we're looking for. We find something else, something stranger, subtler, sometimes more important. And often, it's the journey itself that reshapes us, not the discovery at the end. Drilling into the earth is more than a scientific act. It's a mirror. Every layer we uncover reflects a deeper layer of ourselves, our persistence, our restlessness, our refusal to accept the surface. It's the same force that sends telescopes into the void, that drives submersibles into black oceans, that fuels the endless human instinct to ask why. To look up is to dream. To look down is to confront. And somewhere between the two lies the story of who we are. Creatures standing on a living planet, daring to pierce it, daring to listen to what it has to say. The first drill bit that touched the Kola soil in 1970 carried more than steel and technology. It carried history. It carried myth. It carried the weight of every question humanity had ever asked about what lies beneath. The borehole would go deeper than any before it, and in doing so, would reveal truths and mysteries that would echo for decades. But that is where we are heading next. Because what began as an experiment in geology soon became something else, something the scientists themselves could hardly define. They didn't just break through rock, they broke through certainty. And what they found, and what they heard, would change how we think about the world beneath our feet forever. The space race reached for the stars, but another race reached for the core. While rockets burned upward into the cold vacuum, a quieter, stranger frontier was being claimed below. It was the 1960s, a decade when exploration meant more than discovery. It meant dominance. Every orbit, every satellite, every step on the moon was a declaration of superiority, proof that one ideology could outthink and outbuild the other. But for a handful of scientists, there was another frontier, untouched by politics, unseen by telescopes, a frontier not of sky, but of stone. They weren't dreamers of flight, but listeners of Earth, geophysicists, seismologists, planetary scientists who believed the key to understanding the cosmos might actually lie beneath our feet. And so, while the world watched rockets rise, these scientists turned their gaze downward. In 1957, as the Soviet Union launched Sputnik 1, the first artificial satellite, a group of American geophysicists gathered in a conference room in Washington, D.C. They were part of the American Miscellaneous Society, a deliberately unstructured group of some of the most creative scientists in the country. They called themselves AMSOC, and their purpose was simple: to ask questions no one else dared to ask. Among them was Walter Munk, a visionary oceanographer who believed the next great leap for science wouldn't come from above, but from below. He proposed something radical: drill a hole through the ocean floor, deep enough to reach the Mohorovičić discontinuity, the boundary between the Earth's crust and its mantle. It was known as the Moho, a geological horizon where seismic waves suddenly changed speed, hinting at a profound shift in composition. If scientists could reach it, they could for the first time touch the materials that make up most of the Earth's interior. It would be, in a sense, humanity's first step toward the center of the Earth. They called it Project Mohole. At the time, it seemed just as audacious as the space race itself. To drill through the ocean floor, one had to first drill through the ocean, a vast column of water that no drill rig had ever conquered. It required stabilizing a floating platform over deep water, maintaining a vertical borehole thousands of meters below, and retrieving cores of rock without them shattering or vanishing into the abyss. But audacity was the language of the era. America was competing with a nation that had just launched a satellite, and soon, a man, into orbit. Project Mohole became a way to prove that American science could reach new depths, even as Soviet rockets reached new heights. In 1961, the first experimental drilling began off the coast of Guadalupe Island, Mexico. The platform, a converted barge called the KolaSuperdeep, was equipped with a dynamic positioning system that allowed it to hover precisely over a single point in the ocean, guided by sonar and computer control. This was the birth of modern offshore drilling technology. Over the following weeks, the KolaSuperdeep drilled 5 holes into the seabed, reaching a record depth of 183 meters beneath 3,500 meters of water. It was a small victory, but it proved that the concept could work. For a brief shining moment, the dream of reaching the mantle seemed within reach. But dreams cost money, and money, in the early 1960s, followed spectacle. Space was visible, a rocket launch, a countdown, a flag. The deep Earth was not. No cameras could capture the slow turn of a drill bit miles beneath the sea. No headline could explain seismic velocity anomalies or petrological samples. By 1963, Project Mohole had become a bureaucratic tangle. Costs spiraled, leadership fractured, and Congress lost patience. To many it seemed like a scientific vanity project, a hole in the ocean that swallowed funds and offered no clear reward. The final blow came in 1966, when the U.S. government officially canceled the project. The dream of touching the mantle, America's race to the center, ended in political silence. But silence, as the Soviets understood, can be filled. In the Soviet Union, a similar idea had been germinating quietly, independently, and far from the public eye. To the Western world, the USSR was a monolith of secrecy, but within its laboratories and institutes, brilliant scientists were driven by the same questions as their American counterparts. How deep does the crust truly go? How does it transition into the mantle? And could drilling reveal the planet's hidden processes, earthquakes, magnetic fields, tectonic motion, at their source? In 1965, just as Project Mohole was dying, the Soviet Academy of Sciences announced an ambitious new goal. They would drill the deepest hole in history. Unlike Mohole, this one would be on land, a vertical shaft straight through the continental crust. No oceanic mobility problems, no shifting seafloor, just rock. Miles and miles of ancient, unbroken rock. The location they chose was the Kola Peninsula, a remote, frozen region in northwestern Russia, near the border with Norway. Here, the crust was unusually thick and stable, composed of some of the oldest rocks on Earth, dating back nearly 3 billion years. If they could reach deep enough, they could read Earth's history layer by layer, like pages in a cosmic diary. The project was approved in 1966. It would take 4 years of preparation before drilling began. The world, meanwhile, looked elsewhere. To the moon. To Vietnam. To the headlines. No one outside the Soviet Union paid much attention to a drilling rig in the Arctic, but deep in the tundra, the Soviet scientists built their monument to curiosity. The Kola Superdeep Borehole was unlike anything ever attempted. A drill tower rose from the permafrost like a spire of industry, stark against the endless white of the Arctic landscape. From above, it looked almost insignificant, a single structure surrounded by snow and silence. But beneath it, a journey began that would last 24 years. Drilling officially commenced on May 24, 1970. The plan was to reach 15,000 meters, nearly 50,000 feet by the end of the decade. The equipment was designed to handle immense pressures and temperatures, with a special drill bit that could grind through granite harder than steel. Each meter drilled was a triumph and a lesson. By the time they reached 7,000 meters, the borehole was already deeper than any other on Earth. But the deeper they went, the more unpredictable the Earth became. Temperatures soared far beyond projections. At 12 kilometers, the rock reached 180 degrees Celsius, hot enough to soften the drill bits and warp the cables. The deeper layers didn't behave as expected. They weren't uniform or predictable. They fractured, shifted, and surprised. For all their planning, the Soviet scientists had entered a place no one had ever truly known. Outside the Arctic Circle, the world began to hear whispers of the borehole. Not from official reports, but from the quiet envy of Western geologists, who marveled at the depth achieved. The Americans had stopped at 183 meters below the seabed. The Soviets had gone nearly 12,000 meters beneath solid ground. And yet, there was no propaganda, no grand announcement. The Kola project was not about headlines. It was about knowledge. Still, within the geopolitical theater of the Cold War, knowledge was power. Every discovery carried the weight of potential advantage. Understanding seismic patterns could aid nuclear test detection. Insight into crustal behavior could influence resource extraction. The line between science and strategy was thin, almost transparent. But beneath the rivalry, something quieter persisted. A shared human impulse that transcended ideology. The desire to know. In the laboratories of Moscow and Murmansk, scientists pored over rock samples unlike any ever seen before. Granites from the lower crust, metamorphosed under pressure so great they sparkled with minute crystalline structures. Microscopic fossils, found in rock layers over 2 billion years old. Remnants of ancient microorganisms, preserved in stone far below where life was thought to exist. These discoveries didn't belong to the Soviet Union, or to communism. They belonged to the Earth itself. And yet the world outside knew little of it. Reports were published in obscure scientific journals, untranslated, unnoticed. While astronauts walked on the moon, the deepest humans had ever gone below remained a secret known mostly to scientists and engineers. By the late 1970s, the Kola borehole had reached a depth of 9,583 meters. In 1983, it broke the world record previously held by an oil well in Oklahoma. It was now the deepest hole ever drilled by humankind. No one had ever been this far into the crust of a terrestrial planet. From the surface, the entire structure looked unremarkable, a single steel tower surrounded by barracks and snow. But directly beneath it was a narrow shaft that defied imagination. A tunnel only 9 inches wide, descending nearly 12 kilometers into the earth. If you dropped a stone from the surface, it would take nearly a full minute to hit the bottom. And when it did, it would strike a place hotter than any furnace, older than any fossil, quieter than any tomb. To the engineers, each meter of progress was both a victory and a warning. The machinery groaned under forces it was never meant to endure. Cables twisted like serpents under heat stress. Rock strata behaved like liquid, closing in on the drill bit. It was as though the Earth itself resisted intrusion, reminding its explorers of their limits. But the scientists pressed on. Not for glory, but for answers. The deeper they went, the more they realized how little they understood. At 11 kilometers, seismic data showed anomalies, waves that should have bounced cleanly instead scattered, echoing like murmurs through fractured stone. It was as if the planet were whispering in a language we had not yet learned to hear. Those anomalies would later give rise to myths, stories of sounds from hell, of cries beneath the surface. But in truth, they were something else entirely. The voice of a living planet, speaking through pressure, temperature, and time. By the end of the 1980s, the Cold War itself was changing. The race between superpowers was losing its velocity. The world had grown weary of competition. The great empires were aging, distracted, dissolving. And somewhere in that fading contest, the Kola borehole reached its final depth, 12,262 meters, a number that stood for both triumph and futility. The deepest humans had ever gone, and yet not even halfway through the crust. The machinery could go no further. The heat was too great, the rock too unstable. Even the most advanced drill bits melted under the pressure. On the surface, the Soviet Union itself was nearing collapse. The Kola project, once a symbol of ambition, became an artifact of another era. By 1992, the site was abandoned, the borehole sealed, the equipment left to rust under Arctic snow. But even as the tower fell silent, the echoes of that descent continued to shape science. The data collected from the Kola borehole rewrote our understanding of the continental crust. It revealed that seismic layers didn't always match physical ones. That water, ancient, mineralized water, could exist kilometers below the surface. That life, or at least its traces, could survive far deeper than anyone had believed. It also revealed something intangible, that even in an age defined by rivalry and politics, curiosity could carve its own path through the noise. The Kola Superdeep Borehole wasn't a monument to the Cold War. It was a monument to the persistence of wonder, a quiet triumph born from an era of conflict. The Cold War sent humanity in two directions at once, upward, into the stars, and downward, into the earth. Between them lay everything we are capable of: invention, ambition, hubris, and awe. We reached the moon, and we touched the mantle's edge. We mapped the heavens, and we listened, for a moment, to the murmurs of the deep earth. Both journeys began with the same impulse: to go where no one had gone before, to see what no one had seen, to understand, even when understanding might change us. The Americans looked upward, the Soviets looked downward, and together, they proved that curiosity transcends the boundaries we draw around it. They didn't just break through rock, they broke into a silence that had lasted for billions of years, and in that silence, they found not the end of mystery, but its beginning. At the edge of the Arctic Circle, a steel tower rose, not toward the sky, but into the earth. In a landscape where nothing grew taller than the wind, it stood alone, a vertical line drawn against the horizon, pointing downward into the invisible. This was the Kola Superdeep Borehole, the deepest hole humanity has ever drilled. But to understand what it meant, and what it took, we have to go there, not in distance, but in feeling. To the tundra, to the silence, to the edge of everything familiar. The site lay near the small settlement of Zapolyarny, on the Kola Peninsula, a place of relentless winters and midnight suns. For most of the year, the air was brittle and sharp, the kind that turned breath into crystals and machines into slow, reluctant things. The ground was frozen, the wind unbroken. There was no forest here, no shelter. Only rock, snow, and the sound of drilling, a mechanical heartbeat in a barren world. It was an unlikely place for one of humanity's boldest scientific experiments. But perhaps that was the point. The Kola Peninsula, geologically speaking, is one of the oldest pieces of Earth's crust, part of the Baltic Shield, a formation of granite and gneiss, over 2.7 billion years old. If scientists wanted to read the history of the planet, this was the archive. The site's isolation wasn't a hindrance, it was a kind of purity. Far from cities, far from interference, the borehole became a temple of silence, a place where the planet could speak uninterrupted. Building it was no simple task. In 1970, the Soviet Union's Ministry of Geology began constructing a drilling complex unlike any other. They called it SG-3, short for Super Deep Borehole No. 3. It was part laboratory, part industrial fortress, an array of generators, control stations, and dormitories arranged around the central rig. Everything had to be shipped in over rough roads, every cable, every bolt, every ton of fuel. At the center of it all stood the drill tower, 40 meters high, gleaming against the pale sky. Inside, a column of drill pipes stretched downward, connected section by section, each threaded steel tube lowering the bit deeper into the planet. The drilling fluid, a dense, carefully engineered mixture, circulated constantly, cooling the bit, carrying fragments of rock back to the surface. Every fragment was a message from below. Each shard of stone, each grain of dust told a story written under pressure and time. Scientists cataloged them meticulously, marking depth, temperature, texture, color, building an anatomy of the unseen. Drilling downward isn't like building upward. Every additional meter adds weight, friction, risk. At the surface, gravity is an ally. But in the depths, it becomes an enemy, pulling, twisting, threatening to snap the miles of steel hanging from the rig. At 10 kilometers, the string of pipes weighed over 200 tons. Every rotation, every vibration, carried the possibility of disaster. A slight miscalculation could cause the drill to jam or break, and once a section of pipe was lost, it could never be retrieved. The Earth doesn't yield easily. It resists. But the team at Kola persisted with the patience of artisans and the precision of surgeons. Each advance was measured not in leaps, but in millimeters. Drilling was stopped constantly to replace bits, recalibrate sensors, measure temperature and pressure. Progress was slow, excruciatingly so, but steady. For the scientists stationed there, life at the Kola borehole was a strange mixture of monotony and awe. Most lived in temporary housing built near the rig, rows of prefab buildings painted in muted blues and greens, like misplaced fragments of a small industrial town. Inside, the rooms were warm, the air thick with the scent of oil, metal, and instant coffee. There were no families here, no markets or theaters, only long hours and endless daylight in summer, endless darkness in winter. Yet within that isolation grew a kind of camaraderie. Physicists, geologists, and engineers shared meals in a communal canteen, their conversations blending science with humor, speculation, and the occasional philosophical drift. They were pioneers not in spacesuits but in lab coats and wool hats. Their frontier was the unseen. In letters and journals, some of them wrote about the strange duality of the place, how the drilling rig seemed alive, how the sounds from below became part of their dreams. The rhythmic pulse of machinery, the soft roar of generators, a lullaby of progress echoing across frozen stone. They were aware that their work was being watched, though quietly, by the outside world. Scientists from other countries occasionally visited, invited to tour the site, to see the world's deepest hole. They would stand at the edge of the borehole, a small, circular opening capped with a heavy metal lid, and realize that beneath their feet was 12 kilometers of darkness. They said it felt like standing on the edge of time. The process of drilling evolved continuously. In the beginning, they used traditional rotary drilling, a mechanical bit grinding through rock. But as depth increased, so did the challenges. Temperature and pressure rose beyond what the equipment was designed to handle. At several points, the drill bit would seize or twist, forcing the team to halt operations and pull thousands of meters of pipe back to the surface. Each retrieval took days. Eventually, Soviet engineers developed a specialized system called UD4, a custom-built deep drilling apparatus with remote sensors and reinforced drill strings. It was one of the most advanced systems of its time, a triumph of Soviet engineering that quietly rivaled the space technologies being built elsewhere in the country. The deeper they went, the more they learned, not only about the Earth, but about the limits of their own invention. Rock, under such pressure, behaves like a slow-moving fluid. What should have been solid strata flowed, closed, shifted. At certain depths, they could actually hear the walls of the borehole creaking, the Earth adjusting to their intrusion. Imagine the cross-section of the planet as they saw it, a vertical line through layers older than life itself. At the top, weathered granite and glacial debris. Below that, metamorphic rock formed in the heat of ancient collisions. Deeper still, layers of sediment that had once been seabeds, now compressed into sparkling stone. At 8 kilometers, they reached rocks over 1.5 billion years old. At 10, the temperature had risen beyond 150 degrees Celsius, far higher than predicted. At 12, it surpassed 180 degrees, hot enough to deform metal. It was here that their instruments began to fail, their sensors flickering, their measurements inconsistent. The data that came from these depths often defied expectation. Seismic reflections didn't match known models, sound waves slowed where they should have sped up. Theoretical boundaries between crustal layers blurred or vanished. The scientists found themselves not confirming geology, but rewriting it. Yet for all the complexity of the work, there was a simplicity to the daily rhythm of the borehole. Mornings began with the sound of machinery warming in the cold. Technicians checked pressure gauges, engineers calibrated the torque of the drill, scientists reviewed the previous night's data. Each rotation of the bit brought up tiny fragments of rock, the only tangible connection to the deep world below. They would wash the samples, dry them, label them, 10,004 meters, 10,117, 10,223, numbers that marked not just depth, but persistence. There were moments of triumph, when a new depth record was set, when an unexpected fossil or mineral was found, followed by long stretches of quiet endurance. Weeks when nothing seemed to change except the color of the sky. But even in that monotony there was meaning. To them, every small success was a step toward understanding something immense. Visitors who came to Kola often described a strange feeling that lingered there, a sense of standing at the threshold of something vast and indifferent. The Arctic wind never stopped blowing. The light, when it came, was low and golden, stretching shadows across the rig. At night, when auroras shimmered above the camp, the steel tower looked almost like an antenna between worlds, receiving signals not from the heavens, but from the depths. It wasn't a place for the faint of heart. Drilling required constant maintenance. The machinery froze in winter, and in summer, swarms of insects filled the air. Communication with the outside world was limited, yet no one there seemed disheartened. They were part of something larger, an experiment that reached beyond politics or era. One engineer described it simply, "We were listening to the earth breathe." By the late 1970s, after nearly a decade of work, the borehole had reached over 9 kilometers. To celebrate, the team held a small gathering in the control room. There was no champagne, no ceremony, just tea, laughter, and the quiet recognition that they had gone further than anyone before them. Still, they weren't satisfied. They wanted to reach 15 kilometers. to cross the theoretical boundary between the crust and the mantle, to touch the transition zone that separated the world we live on from the one that lives beneath. They knew the risks. The deeper they drilled, the greater the pressure on every bolt, every seam, every human mind that had to maintain vigilance. But they also knew that discovery never comes without danger, and that the line between progress and failure is always drawn in hindsight. The data arriving from the lower depths was already changing geology textbooks. They found that seismic discontinuities didn't correspond neatly to physical layers of rock. That granite could metamorphose under conditions previously thought impossible. That the crust was far more complex and unpredictable than any model suggested. They also found traces of water, ancient trapped fluid sealed in microscopic pores within the rock. Water that had been there for millions, perhaps billions of years. Its existence suggested that the crust was not as closed and dry as once believed, that even deep below, the planet still carried the memory of its oceans. Each new finding blurred the boundary between surface and depth, past and present. It was as if the Earth, under the drill's patient insistence, was revealing secrets it had kept for eons. For those who worked there, the borehole became more than a scientific project. It became a symbol of endurance, of inquiry, of the human impulse to go further. When they spoke about it, there was pride, but also humility. They knew the limits of their knowledge. They understood that every answer opened new questions. Some compared the borehole to a mirror. The deeper they looked into it, the more it reflected their own persistence and their own smallness. When the site's director, David Guberman, was asked why they kept going, he replied simply, "Because we can. Because we must know what's below." By 1983, they had reached 12,000 meters. It was a record that still stands. At that depth, the rock itself became unpredictable. Seismic waves behaved erratically. The temperature climbed higher than models could explain. The crust, it seemed, was not a fixed structure, but a living system, one that flexed, shifted, and spoke through vibrations. For the scientists, it was exhilarating and unsettling all at once. The Earth was stranger than they had imagined, not a static mass, but a dynamic organism, a planet still writing its own story beneath their feet. By the time the 1980s drew to a close, the Kola Superdeep Borehole had become both a triumph and a mystery. The deeper they drilled, the less predictable the results became. The equations didn't match the evidence. The instruments faltered. The planet, it seemed, resisted definition. And that resistance, that refusal to be fully known, may have been the borehole's greatest revelation. Because it reminded us that exploration isn't about reaching the end. It's about realizing there might not be one. They had gone 12 kilometers down, through time itself, through rock older than continents, older than oxygen, older than life. And yet, even there, the Earth kept its secrets. But the deeper they drilled, the stranger the data became. At 12 kilometers down, the drill bit met heat so intense, it bent steel like wax. For nearly 2 decades, the team at Kola had been fighting gravity, rock, and time itself. But in the end, it was something invisible, something elemental, that stopped them. Heat. When the project began, the scientists had built their models carefully. According to seismic data and temperature gradients, they expected a rise of about 1 degree for every 100 meters. By 12 kilometers, that should have meant roughly 100 to 120 degrees Celsius. Extreme, yes, but manageable. Their equipment was designed for it. Their calculations accounted for it. But reality did not. When sensors reached that depth, they recorded temperatures exceeding 180 degrees Celsius. Metal softened, cables distorted, lubricants burned away. Even the drilling mud, the fluid meant to cool the system, began to lose its viscosity, behaving more like vapor than liquid. It wasn't just a technical setback. It was a revelation. The Earth was not following our equations. The deeper they drilled, the more it seemed that their knowledge, precise, structured, elegant, began to unravel. The temperature anomaly wasn't merely inconvenient. It rewrote the understanding of heat flow in the continental crust. The gradient was far steeper than models allowed. That meant the rocks at 15 kilometers could exceed 300 degrees, hot enough to melt drill bits outright. At those depths, pressure joined in the assault. The weight of the overlying rock compressed the walls of the borehole, squeezing it closed. The drill bit would seize, twist, or snap, a steel serpent crushed by the weight of its own ambition. The engineers tried everything, adjusting drilling fluids, redesigning bits, developing new alloys. They extended cooling systems, experimented with pressure modulation, and even planned new temperature-resistant sensors. But nature refused cooperation. Every time they descended again, the same thing happened. The heat rose faster than prediction, the metal warped and the walls shifted. It was as if the Earth itself was sending a message. This far, and no further. From the surface, it might have looked like a technical problem, a matter of equipment or calibration. But to those who lived it, it felt like something larger. The scientists had spent years mapping, measuring, and modeling, believing that the planet was a system to be solved. Now, that system was staring back, alive, unyielding, and far more complex than any human mind could contain. One engineer described it simply: the rock began to move as if it were breathing. At 12 kilometers, granite behaved less like stone and more like clay. Under immense pressure and heat, it deformed slowly, almost imperceptibly, closing in around the borehole like flesh around a wound. It wasn't breaking, it was healing. The Earth, disturbed, was restoring itself. They realized that drilling wasn't just a mechanical act, it was a dialogue. Every rotation of the bit, every vibration through the rock, every echo returning through the sensors, it was all communication. And now, the planet was responding in kind. Inside the control room, the scientists watched the readings in disbelief. Temperature, pressure, sonic velocity. The numbers flickered, then stabilized, then flickered again. They recalibrated instruments, double-checked thermocouples, ran diagnostics. But the data remained the same. It was hotter than theory allowed. They took samples of the rock, dark, crystalline fragments brought up through the mud. When they touched them, they radiated warmth even after minutes in the Arctic air. Geologists examined them under microscopes, marveling at the metamorphosis within. Minerals rearranged, quartz veins fused, microfractures sealed by ancient heat. It was geology alive in slow motion. The borehole had become a paradox, a place where time, temperature, and matter all began to blur. Outside, life continued in strange contrast. Above ground, the Arctic wind howled, carrying snow across the metallic complex. Frost formed on railings, engines, eyelashes. The horizon remained frozen and still. Below, less than half a meter wide, the Earth seethed with heat and pressure. A world so different it might as well have been another planet. A place untouched by sun or storm. A world of pure interiority. The scientists would often walk out after long shifts, stepping into the endless daylight of northern summer. They'd stand in silence, staring at the steel lid that sealed the borehole. Beneath their boots, 12 kilometers of unknown churned and shifted. One geophysicist later wrote, "It felt like standing above a living thing, not dead rock, but something breathing slowly, patient, immense, beyond comprehension." They had reached the point where every hypothesis began to dissolve. If heat could rise faster than expected, what else might be wrong? The structure of the crust, the behavior of seismic waves, the interpretation of Earth's composition, all were suddenly in question. It became clear that the models humanity had built, the clean diagrams dividing crust, mantle, and core, were simplifications, abstractions of a reality that refused to stay still. In truth, the Earth wasn't a static structure, it was an organism in flux. Solid rock flowed. Pressure generated currents of heat. Matter behaved like liquid at one scale and crystal at another. Science wasn't failing, it was evolving. The borehole wasn't disproving knowledge, it was deepening it. Still, the practical limits were impossible to ignore. At 12,262 meters, progress stopped. The drill simply couldn't go further. The temperature was too high, the equipment too fragile, the risk too great. The world's deepest hole had reached its end, not in triumph, but in surrender. But what they had found along the way was worth more than another kilometer of depth. Core samples revealed the existence of microscopic fossils, planktonic remains trapped in metamorphic rock nearly 7 kilometers below the surface. That meant these rocks, once part of the ocean floor, had been buried and transformed over unimaginable time. Life had been deeper, older, and more persistent than anyone had guessed. They also found traces of hydrogen gas, pockets so dense and concentrated that the drilling mud sometimes boiled as it surfaced. Hydrogen, born from reactions in the crust, hinted at chemical processes still active beneath the continents. It was a reminder that beneath our feet, the Earth was not a finished creation, but a continuous experiment. For every discovery, new mysteries emerged. Why was the temperature gradient so steep? Why did seismic waves slow at unexpected depths? What was the true boundary between crust and mantle, and did such a boundary even exist in the way we imagined? The deeper they looked, the less the Earth resembled the planet of textbooks. It became stranger, more alive, more unpredictable. In Moscow, reports from Kola began to attract international attention. Scientists from the United States, Europe, and Japan were astonished by the findings. The Kola team published their results, datasets filled with contradictions and anomalies that no one could easily explain. Some saw it as a challenge, others as a humbling reminder that our planet remains mostly uncharted, even from within. And yet, the name Super Deep Borehole began to take on a mythic tone. The public, far removed from its scientific rigor, began to imagine what might lie at those depths. Rumors spread, distorted retellings of temperature data and seismic readings, until they became something else entirely. But that is another story, one built on echoes and misunderstandings. For the scientists at Kola, the truth was simpler and far more profound. They hadn't reached the core of the Earth, but they had reached the limits of knowledge and in doing so glimpsed its horizon. The day drilling finally stopped. The camp was quiet. No ceremony, no announcement, just the subtle silence of engines powered down for the last time. The borehole, capped with a heavy steel plate, sat beneath the Arctic light like an artifact from another world. Some of the scientists lingered, running their hands over the metal lid. Beneath it lay 12 kilometers of human ambition and 12 billion years of Earth's memory. They had entered the crust like archaeologists of existence itself, and what they found was both humbling and infinite. In the control room, old logs recorded the final temperature, 180 degrees Celsius. The final depth, 12,262 meters. And the final note, handwritten by a geologist, read simply, "Further drilling impossible due to high temperature." 3 short words due to temperature, closing a chapter of exploration that had taken 2 decades and rewritten a science. But in a way, the project never truly ended. The borehole still exists today, though sealed, its machinery dismantled, its corridors abandoned to frost and time. Satellite images show the empty clearing, the faint outlines of foundations, the quiet mark where humanity's deepest scar once reached toward the core. Standing there now, you would see nothing extraordinary, just tundra, rock, and a rusting steel cap. But beneath that silence lies a journey that changed how we see the planet itself. It proved that knowledge has boundaries, and that those boundaries are alive. It showed that beneath the logic of science, there is still wonder, and beneath our feet, still mystery. The Kola Superdeep Borehole never reached the Earth's core. It didn't uncover hell or paradise or any mythical secret. But it did reveal something far more human. That curiosity, even when it fails, leaves behind its own kind of light. Because they didn't reach the core, but they reached something even deeper. Questions. When they listened to the depths, what they heard wasn't screaming. It was history, whispering through stone. After the drills went silent, the real work began. For nearly 20 years, the scientists of the Kola Peninsula had been carving a line downward, a scar through the oldest rock on Earth. Now, they turned their attention to what they had brought up. The samples were small, fragments of stone no larger than a fist, but they held entire epochs within them. Each layer carried evidence of ancient worlds, oceans that had dried, continents that had collided, and the slow, unbroken march of geological time. To hold one of those pieces was to hold time itself, compressed, metamorphosed, and heated to nearly 200 degrees. When examined under a microscope, something extraordinary appeared. The delicate outlines of microscopic fossils, the remains of planktonic organisms that had once floated in primordial seas. They were entombed in metamorphic rock nearly 7 kilometers below the surface. For the scientists, this was more than a curiosity. It was proof that the granite beneath their feet had once been part of the ocean floor, a seabed that had been subducted, transformed, and reborn over billions of years. They were looking not at death, but at transformation, at the story of life folded back into the crust from which it had come. In a small laboratory above the borehole, geologist Ludmila Suvorova examined those fossils day after day, adjusting the microscope's light until their shapes emerged. Tiny spirals, filaments, and traces of carbon where once there had been cells. She described them as ghosts of the ocean, trapped in the memory of stone. These microfossils, preserved at unimaginable depths, changed the understanding of how life and geology intertwine. They suggested that even the oldest rocks on Earth were not lifeless relics, but vessels, carrying the imprints of existence across eras. The borehole had not reached the core, but it had reached a chapter of the planet's autobiography that had never been read before. Beyond the fossils, Other anomalies appeared, subtler but equally unsettling. When seismic readings were taken from within the borehole, the data showed something unexpected. Sound waves traveled slower through certain layers of rock than models predicted. According to established theory, those layers should have been solid granite, dense, uniform, stable. Instead, they behaved like something softer, almost sedimentary. It was as though the Earth's deepest foundations were not as rigid as we imagined. This baffled geophysicists. For decades, seismologists had used the speed of sound waves to map the planet's interior, building models of crust, mantle, and core. Those models relied on the assumption that deeper meant denser, that as you went down, matter became more compact, more uniform. But Kola's data suggested the opposite. At extreme depths, the rock wasn't homogeneous. It was fractured, porous, filled with microcavities. In other words, the Earth was less a solid body and more a living lattice, a structure capable of storing and releasing energy in ways we barely understood. To understand what they'd found, the scientists began replaying the sonic data, the echoes from sensors deep in the borehole, recordings of how vibrations bounced and scattered through the rock. What they heard wasn't sound in the ordinary sense. It was data transformed into frequency, vibrations translated into human range, a series of irregular pulses, low and resonant, rising and falling like breath. To some, it sounded eerily organic. To others, like machinery buried in stone. But to the scientists, it was simply evidence of the crust's complexity, a soundscape of compression waves and microfractures, a language of pressure and temperature. Years later, fragments of those recordings would resurface, stripped of context, altered, shared. Someone added distortion, layered in echoes, and claimed they were the sounds from hell. It was 1989 when the rumor first appeared, a broadcast on a Christian radio program in the United States, claiming that Soviet scientists had drilled into the underworld and recorded the screams of the damned. The story spread like wildfire. Newspapers repeated it. Television hosts debated it. Cassette tapes circulated filled with what sounded like human wailing beneath roaring static. It was horrifying and captivating. People wanted to believe that the hole had reached something forbidden, that science had trespassed where faith warned us not to go. But none of it was true. The Kola scientists had never recorded anything resembling voices. The screams were audio fabrications, composites of looping effects taken from movies and public sound archives. What began as a myth spread as a kind of cultural fever, a reflection not of the borehole, but of the human need to fill silence with meaning. Because in truth, the Kola Superdeep Borehole is silent. It always has been. No wind, no air, no sound that could carry through 12 kilometers of dense rock. What the scientists heard were vibrations, echoes of earthquakes, fractures, and heat. But when people heard about those vibrations, they turned them into metaphor. The sounds from hell weren't lies in the malicious sense. They were a story about how we confront the unknown. When faced with a hole so deep it disappears into darkness, our minds do what they have always done. They listen for voices. And yet, behind the myth, the real data was stranger than fiction. At depths where light and air had never existed, the sensors detected anomalies in density and magnetism, tiny fluctuations in the rock's magnetic field, as though the planet's internal pulse was beating faster at certain layers. These readings suggested that the crust was more dynamic than expected, its minerals shifting subtly, producing electrical currents under stress. It was geology as living energy, the slow heartbeat of a planet still evolving. Some of these effects might explain natural phenomena we still puzzle over today, mysterious ground hums, low-frequency tremors, or the earthquake lights seen before major seismic events. The borehole didn't uncover supernatural sounds, but it did reveal the Earth's capacity to speak, not in words, but in the language of resonance. For the researchers, this was both humbling and exhilarating. They were beginning to glimpse the planet not as a static sphere, but as a living continuum, an organism of heat, pressure, and vibration. Each anomaly, each unexplained echo, reminded them how little we truly know of the ground beneath us. Dr. David Guberman, the project's director, once said, "When you look at the Earth from space, you see the surface. When you look from Kola, you see its soul." What he meant was simple. From above, the planet looks serene, blue oceans, white clouds, steady continents. But from below, it is restless, dynamic, and ancient beyond imagination. To listen to it is to listen to deep time itself, to feel the slow, patient rhythm of a planet that has been evolving for 4.5 billion years. The borehole's seismic studies also revealed something unexpected about earthquakes. Traditional models suggested that seismic energy travels predictably through the crust, that the boundaries between layers are sharp, defined. But the data from Kola showed that these boundaries blur and bend. Some layers even refract energy back upward, creating echoes that could be mistaken for secondary tremors. This insight helped refine global models of earthquake behavior. It explained why seismic waves sometimes appear to bounce inside the Earth, and why predicting quake intensity remains so difficult. In a quiet way, Kola changed not just geology, but how we understand the living pulse of the planet. Still, the most haunting part of the project was not what it found, but what it represented. The borehole became a kind of metaphor, a symbol of humanity's endless descent into knowledge. It showed how curiosity can pierce through stone, and how mystery always seeps back in to fill the space we clear. Because at a certain depth, science and philosophy meet. At a certain temperature, fact begins to resemble myth. And at a certain silence, even the most rational mind begins to listen for whispers. When the project finally ended, many of its scientists moved on to other fields: oil exploration, mineralogy, seismology. But some continued to analyze the data long after the site was abandoned. Even today, decades later, research papers still cite Kola's readings, its measurements of heat flow, seismic velocity, and magnetic anomalies. In the language of science, the borehole never closed. It continues to speak through its data. And yet, outside the academic world, its memory has shifted from an engineering feat to a modern myth. A legend whispered on internet forums, a clickbait headline promising the hole to hell. It's a strange fate for a project born in the quiet rigor of geology to become a ghost story about the limits of human knowledge. But maybe that's fitting, because the Kola borehole was never just about rock and heat. It was about listening, about hearing the planet's deepest silence, and mistaking it, perhaps inevitably, for something calling back. In one of the final reports, a Soviet geophysicist wrote, "We have reached depths where the rocks remember. Every fracture, every mineral layer, carries an echo of what came before." It's a poetic line, buried in a technical paper, but it captures something essential, that even the most lifeless stone holds memory. When pressure builds, it leaves scars. When continents collide, it leaves seams. When oceans recede, they leave fossils, tiny remnants of existence folded into the crust. If the planet could speak, those would be its words, not cries or screams, but the low murmur of time itself. The myth of the sounds from hell fades when faced with fact. But what remains is even more haunting. The realization that we are standing on a world alive with echoes, vibrations that have traveled through billions of years to reach us. Every earthquake, every tremor, every shifting fault is part of that ongoing dialogue between surface and depth. And when we listen closely, through sensors, through science, through silence, we are not hearing horror. We are hearing continuity. The Kola Superdeep Borehole didn't open a gateway to another world. It reminded us that this one is still full of doors we've yet to open. The data it produced continues to challenge, to humble, to inspire. And though the drill has stopped, the echoes remain, not beneath the ground, but within us. Because mystery doesn't end with measurement. It begins there. 12 kilometers down, they found life, long extinct, perfectly preserved in stone. Not living life, but the echoes of it. Microscopic fossils sealed inside crystalline granite. The remains of organisms that had once drifted through ancient seas billions of years before any human ever dreamed of reaching so deep. For decades, scientists believed such fossils couldn't exist at those depths. The heat, the pressure, the sheer metamorphosis of the rock should have erased every trace of organic form. Yet under the microscope, there they were, tiny, carbonized silhouettes etched into the mineral lattice, like the fingerprints of vanished oceans. Each sample retrieved from the borehole was a fragment of deep time, carried upward through 12 kilometers of darkness. When the cores were sliced and polished for study, they revealed a cross-section of Earth's memory, a timeline compressed into millimeters, folding billions of years into a single piece of stone. At around 7 kilometers, the team found sedimentary layers, once the bottom of an ancient ocean, that had long since been buried, crushed, and transformed into high-grade metamorphic rock. Inside them, trapped in the spaces between crystals, lay the fossils. Tiny single-celled organisms, now nothing more than shapes in carbon. They were estimated to be at least 2 billion years old. A reminder that even beneath continents and mountain ranges, the remnants of life persist. In a sense, the borehole had drilled into the ocean floor, not the one we see today, but one that had existed before the continents took their present form. Before trees, before fish, before oxygen had fully saturated the sky. This was Earth in its early biography, a world half-formed, alive with microbial seas and tectonic forces rearranging themselves for the first time. The fossils didn't just challenge geological assumptions. They blurred the boundary between life and matter, between biology and geology. Because if life's traces could survive 2 billion years of heat and compression, then perhaps the story of life isn't written only in bone or DNA, but in the very minerals of the Earth itself. The scientists who examined the samples spoke about them with a kind of quiet reverence. They knew they weren't just studying rock, they were studying memory, a record written not in language, but in structure and form. Each fossilized curve, each chemical residue, was a syllable in the story of survival and transformation. It forced them to reconsider what the Earth truly is. Not a passive sphere of minerals, but a living archive, an organism that records everything it endures, from the cooling of magma to the breath of ancient plankton. The planet remembers, not through intention, but through persistence. Under the microscope, the fossils looked almost delicate, traces of shells, spines, and filaments, suspended in mineral lattices that shimmered with mica and quartz. The scientists described them as life in negative, as though existence had left its own shadow behind. Some of these microfossils showed complex structures, suggesting early multicellular coordination long before the Cambrian explosion had filled the seas with animals. Others were simple, just threads of carbon where once there had been movement. But all of them spoke the same truth, that life and Earth are not separate forces, but two expressions of the same enduring chemistry. It's easy to forget that the ground beneath us was once alive, that every continent was once sediment, every mountain once seabed, and every stone a remnant of something that moved, breathed, or grew. The fossils from Kola were like a message from that forgotten world, a whisper from a planet that has been all things, molten and frozen, barren and lush, dead and reborn. And in that whisper was a kind of humility. Because even in the heart of the most solid rock, the imprint of life endures. One of the project's lead paleobiologists, Dr. Yelena Vityazeva, wrote in her field notes, "The deeper we go, the older the world becomes, yet its traces of life persist like handwriting on wet clay." Her words reveal the awe that infused the work. These were scientists surrounded by drilling rigs, by the cold metallic smell of machinery and oil, yet what they were uncovering was delicate beyond comprehension. A record not of machines or metals, but of biology in its earliest whisper. The discovery of microfossils deep in the crust also raised profound evolutionary questions. If remnants of life could survive in metamorphic rock that had once been buried beneath oceans and then uplifted into continents, what did that mean for our understanding of how and where life began? Could life itself have deeper roots than we realize? Not just at the surface, but within the planet's own architecture. Subsequent research has shown that microbial ecosystems do exist far below ground, thriving in rock pores, feeding on hydrogen and minerals, living in near-total isolation from sunlight. The Kola fossils, though long dead, hinted that such deep biospheres might have ancient origins, perhaps stretching back to the dawn of life itself. In a way, the borehole became not just a window into the past, but a mirror, reflecting life's persistence, even in places where it shouldn't exist. If you could stand at the rim of the Kola borehole today, you'd see nothing more than a sealed metal plate in the middle of an empty tundra. The air is cold, the horizon endless, the sound, just wind. But beneath that silence lies a history longer than human language. Every meter of that depth corresponds to hundreds of thousands of years, each layer a memory, compressed until time itself becomes physical. To look into that void, even just in imagination, is to sense that the Earth is not merely old, but alive with age. The notion of the Earth as an archive isn't new. Ancient philosophers like Xenophanes and Aristotle already suspected that the mountains once lay beneath the sea, that the fossils embedded in cliffs were remnants of older worlds. But never before had humanity touched those depths directly. Never before had we drawn the archive itself up from the dark and held it in our hands. The Kola borehole did more than pierce the crust. It pierced time. Through it, the planet revealed not just its layers, but its capacity for remembrance. Even now, the samples from the borehole sit in sealed containers, stored in laboratories across Russia. To most, they look unremarkable, gray rock, flecked with minerals. But to those who know their story, they are as sacred as any relic. Inside them are the outlines of life forms that existed before oxygen, before continents, before even the sun shone as brightly as it does today. When scientists study those stones, they are, in a sense, reading Earth's autobiography. A story told not in words but in textures, layered, fractured, reassembled. And perhaps this is the deeper meaning of the borehole. That even as we drill into the unknown for knowledge, what we find is a reflection of ourselves, our desire to remember, to preserve, to connect the present with the unthinkably ancient. For in studying the Earth's memory, we are reminded of our own fragility. Our civilizations rise and fall in centuries. Mountains form and erode in millions. Yet somewhere beneath us, in silence and pressure, the traces of life remain. It is easy to imagine those fossils as the planet's neurons, tiny imprints of experience, carrying forward what came before. And if that metaphor holds true, then perhaps the Earth itself is conscious in its own slow way, not in thought, but in continuity. Each layer builds upon the last, just as memory builds upon experience. We are not separate from that process. We are its latest expression, temporary shapes in the same enduring stone. Standing above the sealed borehole, one might wonder whether the planet has more to tell us. Stories of lost atmospheres, vanished ecosystems, extinctions and rebirths we have yet to uncover. Because if the past sleeps beneath us, what else might lie waiting? When the machines fell silent, the stories began. For nearly 20 years, the Kola Superdeep Borehole had been a sound, a constant vibration in the frozen air of the Arctic Circle. Metal turning, gears grinding, the unbroken rhythm of curiosity made mechanical. And then, one day, it stopped. The drills cooled. The lights went dark. The steel tower that once reached toward the sky, or rather into the earth, stood motionless. After 12,262 meters, the deepest hole humanity had ever made was no longer growing. It had reached its limit, not in ambition, but in nature. The temperature, at those depths, had exceeded 180 degrees Celsius. The rock behaved like plastic. The instruments began to fail. Every meter gained required more energy, more cooling, more cost, until the project became unsustainable. The Soviets had conquered a frontier of knowledge, but the Earth itself had the final say. By 1992, as the Soviet Union collapsed, so too did the funding, the momentum, and the ideology that had once fueled such vast experiments. The borehole was sealed, its laboratories abandoned to frost and wind. Papers were boxed and archived, data reels stored in metal cabinets. A few final photographs were taken, the drill site half buried in snow, the steel framework rusting in silence. And in that silence, something remarkable happened. The Kola borehole began to speak again, not through science, but through story. At first, it was simply forgotten. A relic of a vanished era, its coordinates left off new maps, its access roads swallowed by tundra. But human curiosity does not stay quiet for long. Rumors began to surface, strange tales of what the scientists had really found. Stories of heat so unbearable that it melted sensors, of equipment that failed not from pressure, but from something else entirely. And then, inevitably, came the legend. The sounds from hell. It began, as myths often do, far from the truth. In the late 1980s, a U.S. radio program claimed that Soviet scientists had lowered microphones into the borehole and recorded the screams of the damned. The story was absurd, yet gripping. A hole to hell, drilled by human hands. It was irresistible. The host described scientists fleeing the site in terror, claiming they had sealed the borehole forever. He even played a recording, a cacophony of screams and heat, fabricated from movie sound effects and crowd noise. People believed it. Letters poured in. Churches cited it as proof of spiritual truth. News outlets repeated it, sometimes with skepticism, sometimes without. By the time Soviet officials denied the story, the myth had already taken root. It spread because it filled something deeper, a psychological need to explain the inexplicable. When we can't hear what the silence means, we imagine the worst. And so, the quiet borehole became a symbol, not of science, but of forbidden curiosity. The place where knowledge met consequence. It's a pattern older than the story itself. Every age creates its own myths about the unknown, the edge of the map, the abyss of the ocean, the vastness of space. In the Cold War, our unknown wasn't across the sea or sky. It was beneath us. The Earth itself became our last great frontier, and like all frontiers, it invited imagination. But behind the rumor and the folklore, the real ending was quieter, and in its own way, more profound. When the drilling stopped, The scientists didn't seal the borehole in fear, they sealed it in respect. The pressures at depth made further exploration impossible. And yet, even at those limits, they had learned more about the planet's crust than any human civilization before them. They had seen the Earth's temperature gradient firsthand. They had touched layers of rock older than multicellular life. They had revealed that the crust, once thought solid and static, was in fact fractured, dynamic, and alive with energy. The silence that followed wasn't defeat. It was completion. In 2008, a visiting journalist described the site. A barren stretch of permafrost, a single steel cap flush with the ground, and beside it, the remains of buildings once filled with computers and charts. He wrote, "It feels like standing at the edge of something vast, not a void, but a memory." And perhaps that's what silence really is, memory waiting to be heard. Today, if you find the borehole, you'll see that metal cap still there. It's welded shut, stamped with a serial number, unassuming, almost forgotten. But if you stand beside it in the wind, you'll hear a faint hum, not from the earth, but from your own body, blood in your ears, air in motion, the resonance of being alive on a planet that is always moving, even when it seems still. We listen to that hum and wonder if perhaps something is speaking to us from below. But what we're really hearing is ourselves. It's curious how endings become beginnings in human imagination. When the drilling stopped, the scientist had closure. When the story spread, the world found fascination. Both were true, two forms of meaning drawn from the same silence. To the scientists, the borehole was a triumph of geology. To storytellers, it became a myth of consequence, a reminder that curiosity always carries risk. And to philosophers, it became something more abstract. A metaphor for our search for understanding, and the abyss that always answers back with silence. Why do we mythologize what we don't understand? Perhaps because silence feels incomplete. When sound stops, our minds fill the void with narrative. It's the same instinct that makes us see faces in clouds, patterns in static, meaning in coincidence. The silence at Kola wasn't empty. It was a mirror. It reflected our hunger for story, our discomfort with mystery, and our need to transform the unknown into something familiar, even if that familiarity takes the form of fear. And yet, if we strip away the legend, what remains is even more extraordinary. A project born of competition became a monument to curiosity. A machine designed for conquest became a tool of listening, and a hole once thought to reach hell instead touched deep time. The Kola borehole didn't reveal monsters or souls. It revealed the patience of the planet, the way rock folds and reforms, how life leaves its mark even in silence. It reminded us that the earth doesn't hide its truths out of malice. It hides them in plain sight, waiting for us to look closely enough to understand. As the years passed, the site's legend grew even as the real data faded from memory. Digital archives lost to time, paper notes yellowed and crumbled. Many of the original scientists retired or passed away. Their notebooks contained the real treasures, temperature readings, core analyses, diagrams of rock strata. Some of them ended with simple human sentences. Still drilling. No progress today. Heat increasing faster than predicted. Small notes that, when read together, tell a story more honest than any myth. The story of persistence, of listening to the earth until it speaks, and accepting that sometimes it will not. One could say the borehole failed. It didn't reach the mantle. It didn't rewrite physics. It didn't fulfill its grand promise. But perhaps success was never the point. The deeper meaning of Kola lies not in how far we drilled, but in what we were willing to imagine. Every meter of depth was a testament to the idea that understanding requires descent into rock, into time, into mystery. And when we stopped digging, the silence left behind wasn't empty. It was full of what we had learned and what we still didn't know. There's a moment in every exploration when discovery gives way to reflection, when data becomes philosophy, when the noise fades and what's left is the question, why were we listening in the first place? The Kola borehole reminds us that curiosity doesn't always lead to clarity. Sometimes it leads to humility, to the realization that even in our most advanced age, we have only just begun to scratch the surface. If you visit the site now, you'll find nothing that hints at the scale of what was once here. The control rooms are empty, the offices stripped bare. Only a few faded signs remain. Written in Russian, authorized personnel only. Danger, open shaft. Warnings for a danger long gone. The danger was never physical, it was existential. The danger of realizing how small we are against the vast, unyielding memory of the Earth. And yet, perhaps that's the point. Because in that silence, in that absence of sound, something speaks. Not the Earth, not the dead, but the echo of our own curiosity. The same curiosity that looked up at the stars and built rockets, and looked down into the crust and built drills. Two directions of the same impulse, to know what lies beyond the visible. Maybe what we're really listening for isn't beneath the Earth at all. Maybe it's within ourselves, the ancient memory of wonder, the resonance of questions that have no final answers. Every civilization leaves monuments to its curiosity. Some reach upward, others downward, but all of them speak the same truth, that the search itself is sacred. The borehole, sealed and silent, is one of those monuments. It no longer drills, but it still teaches. It no longer hums, but it still echoes. Through science, it showed us the limits of technology. Through myth, it revealed the depths of imagination. And through silence, it reminded us that mystery does not vanish when the noise ends. It begins there. Somewhere beneath that steel plate in the Arctic, the rock still holds its heat. The fossils still sleep. The data still rests in archives, waiting for someone someday to listen again. And maybe they will. Not to prove anything, but to remember that between knowledge and mystery, there is always a thin layer of silence. And that silence, too, has something to say. Every unanswered question is an invitation, not a failure. That's the real legacy of the Kola Superdeep Borehole. It wasn't a conquest of geology, or a race won between nations. It was a conversation between human curiosity and the planet that made us. And like all conversations worth having, it ended not with certainty, but with silence. When the Kola project began, the Earth's crust was mostly theory. Seismic data hinted at its structure, but no one had touched it. No one had felt what 10 kilometers down actually meant. The scientists at Kola weren't trying to reach the core. They were trying to understand the boundary, that mysterious zone where the solid crust meets the molten mantle. They wanted to measure temperature, pressure, and sound velocity, to match mathematical models with reality, to listen, for the first time, to the Earth's own frequencies from within. What they discovered reshaped geology. The first surprise came early. Granite that shouldn't have been behaving like granite. Layers once believed to be uniform turned out to be fractured, veined with fluids that shouldn't exist at those depths. At around 7 kilometers, they found something that stunned even the most skeptical minds. Microfossils, tiny carbonized remnants of plankton, sealed inside metamorphic rock more than 2 billion years old. Life, it turned out, had reached farther and deeper than anyone imagined. But the most significant finding wasn't biological. It was thermal. As the drill descended, the temperature kept rising faster than models predicted. At 12 kilometers, it was nearly 180 degrees Celsius, far hotter than expected for continental crust. That heat wasn't just inconvenient. It rewrote our understanding of the planet's internal dynamics. It showed that the Earth's crust wasn't a static shell, but a living, shifting membrane, a thin layer mediating between two worlds. The cool surface where life thrives, and the incandescent depths where rock flows like liquid. The data from Kola forced scientists to revise how they modeled geothermal gradients, how they interpreted seismic waves, how they understood the very bones of the continents. But there was another lesson, quieter, harder to quantify. The deeper the scientists drilled, the less their models made sense. Sound waves bent unpredictably. Pressure readings fluctuated without cause. The rock itself seemed to resist classification. The borehole became a place where certainty dissolved, where the deeper they went, the less they understood. It was as if the Earth, patient and inscrutable, was reminding them that knowledge has layers too, and that understanding one doesn't guarantee mastery of the next. In that way, Kola mirrored every act of exploration. We set out seeking answers and end up finding better questions. The project began with confidence, the belief that technology could outthink nature. It ended with humility, the realization that nature thinks in time spans we can barely comprehend. That is not failure. That is evolution. Every great experiment begins with precision and ends with poetry. The data points from Kola, the heat, the seismic shifts, the ancient fossils, are all measurable truths. But beyond those numbers lies something immeasurable, the transformation of human perspective. We learned that the crust beneath our feet is thinner, hotter, and more volatile than we thought. That the boundary between solid and liquid Earth is not a clean line, but a gradient of uncertainty, a metaphor for knowledge itself. In the laboratories near the borehole, scientists once joked that they weren't drilling into the Earth, They were drilling into time. Each new core sample was a sentence in a story written over billions of years. Sediments turned to shale, seas turned to stone. Life appeared, vanished, and appeared again, each chapter compressed into layers of rock. To dig down was to read backward, to listen for the voice of the planet as it spoke in the language of pressure and decay. And when the drill could go no farther, they understood something deeper, that even if you reached the end of that story, you would still be standing at the beginning of another. We live on a planet that remembers everything. Every earthquake, every tide, every breath of oxygen that ever filled a lung, all of it written somewhere in the strata. The Kola Superdeep Borehole was our attempt to turn that archive's first few pages. And in doing so, we learned not just about the Earth, but about ourselves, our restlessness, our optimism, our inability to leave mystery untouched. In the 1970s, Soviet geologist David Guberman was asked why the team kept drilling even when progress slowed to a crawl. He said simply, "Because the rock still has something to tell us." That sentence might be the most profound discovery of all. It acknowledges that science is not just about answers, it's about listening long enough to hear what the world wants to say. There's a beautiful irony to Kola's legacy. For decades, humans dreamed of reaching down, to pierce the planet and hold its secrets in our hands. But the deeper we went, the clearer it became that what we were really exploring was not the Earth, but the human capacity for wonder. Every meter of that borehole was a testament to the idea that the unknown is not something to conquer, but something to approach with reverence. We did not reach the mantle, we reached our limits, and that, too, is a form of discovery. In scientific journals, Kola's data still appears, a reference, a footnote, a reminder of what's possible when patience meets persistence. But outside those papers, its story lives on as something more human, a parable of exploration, a meditation on how curiosity shapes civilization. We dig, we listen, we learn, and when we can go no further, we hand the question to the next generation. The deeper lesson of Kola is this. Exploration is not about reaching an end. It's about continually redefining what the end means. The limits of knowledge are not walls, they are thresholds. Each time we reach one, we don't stop. We step forward, sometimes into light, sometimes into silence, always into mystery. In the end, the Kola Superdeep Borehole is not just a place on a map. It's a metaphor carved into the Earth itself. A reminder that even in the most measured acts of science, there is faith. Faith that the world will reveal itself to those who ask with care. And though the hole is sealed now, its echoes remain, in textbooks, in myths, and in the quiet awe we feel when we realize how much lies beneath our feet, waiting to be understood. The Earth still holds its secrets, but we no longer call that mystery a failure. We call it a frontier. Because exploration doesn't end when the machines stop. It ends when curiosity does, and that, thankfully, has never happened. So the borehole remains in silence under snow, a sealed doorway into the past. But its true depth isn't measured in meters. It's measured in meaning. The hole may be sealed, but its echoes reach us still. Maybe the deepest hole we've ever drilled isn't in the Earth, but in our understanding. The Kola Superdeep Borehole was a journey downward, but what it truly uncovered rose upward. Questions, reflections, and a new sense of how little we've touched of what's real. Beneath every act of measurement lies a mystery, and beneath every mystery, a mirror. We like to think of exploration as motion. Rockets leaving the atmosphere, submarines vanishing into the black of the ocean, drills descending into the crust. But exploration is also stillness. It's the moment of silence after a discovery. When you realize that the world has become larger, not because you found something new, but because you understand how much remains unseen. That is what the Kola borehole revealed most clearly. Not the structure of the crust, not the temperature of the deep, but the infinite horizon of unknowing that begins where the map runs out. Every frontier begins the same way, with a simple question that seems to have an answer. What lies below the crust? What lies beyond the stars? What lies inside the atom or the mind? And each time we look, the boundaries dissolve. Atoms open into quarks, space folds into time, rock yields to heat, and heat to silence. The pattern is constant. Every discovery deepens the mystery. Every revelation creates another shadow. It's not failure, it's expansion. We once believed the ocean was infinite. Then we mapped it. We believed the sky was endless. Then we left it. Now we stare inward into genomes, neurons, data, and find the same vertigo waiting there. The Kola borehole belongs to that lineage. It's part of the same story that drives probes beyond the heliosphere and particle accelerators beneath Geneva. It's the same ancient curiosity that made early humans press their palms into cave walls to say we were here. And we wondered. In a way, drilling into the earth is a form of prayer. It's not spoken in words, but in pressure and patience. Each rotation of the drill is a question asked quietly, each core sample a small reply. And like all prayers, the answer rarely comes in the form we expect. We go searching for data and find humility instead. The scientists who stood on that frozen patch of the Kola Peninsula weren't just studying geology. They were participating in something far older, the instinct to descend, to reach toward origins, to touch the foundation of things. From myth to science, the direction of meaning has often been downward. In every culture's imagination, depth is sacred. It's where gods sleep, where ancestors rest, where the unknown waits. And when the Soviets drilled into that ancient rock, they weren't just piercing the crust, they were fulfilling a myth as old as humanity itself. The myth of descent, the need to go below to understand above. Today, our drills are digital. We tunnel into data instead of stone. Our boreholes are algorithms, boring through layers of information, searching for patterns in oceans of code. The terrain has changed, but the drive is the same. To see what lies beneath the surface, of Earth, of matter, of consciousness. Every scientist, every artist, every dreamer is still standing at the edge of that same opening, peering into darkness, listening for something that might answer back. Perhaps that's why the Kola borehole still fascinates us. Not because of what it revealed, but because of what it didn't. It reminds us that even in the age of satellites and simulations, there are places beyond prediction, depths that resist being known. And maybe that's what keeps us alive, the resistance of the world to full understanding. Without mystery, there would be no motion, no stories, no questions, no reason to look beyond the horizon. There's a quiet paradox at the heart of curiosity. The closer we get to truth, the more fragile our understanding becomes. Every model that explains the world is built on assumptions that tremble at the edges. Every map leaves something unmapped. We chase precision, but we live in approximation. And that's all right. Because certainty is not what defines us. Wonder does. Somewhere on the Kola Peninsula, beneath rusted machinery and snow, a metal cap seals the deepest borehole ever made. It doesn't hum, or glow, or whisper. It simply sits there, a circle of silence in the tundra. But if you stand near it, you can almost feel the weight of the world beneath your feet. You can almost sense the distance between here and the mantle, and between knowing and unknowing. That silence isn't empty. It's full of everything we still don't understand. The truth is, the Earth doesn't keep its secrets from us. It keeps them for us. Because mystery is what pulls us forward. We need the unanswered. We need the unseen. Without them, curiosity would starve. Every sealed door, every distant signal, every uncharted depth, they remind us of our unfinishedness. That we are a species built not for completion, but for continuation. In the end, the Kola borehole is just a symbol. A small wound on the surface of an ancient planet. But symbols have power, because they carry emotion beyond fact. And the emotion that lives inside Kola's darkness is not fear. It's longing. The same longing that once built cathedrals, launched telescopes, and whispered to the stars. We are not content to stand still on the surface. We must go deeper, into rock, into sea, into thought. Not because we expect answers, but because the act of seeking makes us more fully human. The philosopher Gaston Bachelard once wrote, "Depth is a dream of the spirit." Maybe that's what the Kola borehole represents, a dream of the spirit made tangible, an act of curiosity so pure that it transcends its outcome. Because even when the drill stopped turning, the descent continued, inward, into reflection, into meaning. Look around at what we explore today, the ocean trenches, the minds of machines, the fabric of space-time. Every field of knowledge is a different kind of borehole, drilled by a different generation of explorers. And though our tools change, our question does not. What lies beneath? Beneath the data, beneath the mind, beneath the silence. Perhaps one day we'll look back at the Kola borehole the way we look at cave paintings, as a beginning. A moment when humanity decided that the surface was not enough. And if we listen closely, beneath the myths and measurements, we might hear what those scientists heard too. Not screams, not signals, but the Earth's quiet exhale, and the echo of our own curiosity calling back. The story of the Kola Superdeep Borehole isn't really about depth, it's about direction. Because every descent into the unknown is also a rise into awareness. Every question we ask of the earth is a question we ask of ourselves. What drives us to dig? To search, to reach beyond what's visible? It's not greed, not pride, but something older, something elemental, a hunger to belong to the mystery that made us. The earth keeps its secrets, but in chasing them, we uncover our own. And that, in the end, is the deepest discovery of all.